going to explain you what is motion clarity based on the Blur Buster's law. And I'm going to start by doing a simple experiment that you can do if you have an OLED at 4K 120 Hz. You set your OLED without any motion blur reduction technique, so no Motion Pro. Just as a sample and hold, we open this UFO test, and we have to make sure that we have the scaling in Windows set to 100%, because this is going to change the resolution of the test. So we need 100% scaling, and we need to make sure that the browser has no zoom, okay? Because that changes the test. So we need 100% zoom, 100% scaling. So when we open this test, the default speed is 960 pixels per second. And I'm going to explain you what that means. But we notice that the UFO test is not clear. It looks blurry at 120 Hz. We also notice that if we reduce the speed, we get better motion clarity. And we have to go all the way down to 120 pixels per second to get a very, very clear image here. So what does that mean? Does that mean that I need 960 Hertz to get that same clarity when the object is moving at 960 pixels per second? Yes, that's exactly what it means. So basically, if you go down to 120 pixels per second at 120 Hertz, the image looks very clear. If you want the same result when the image is moving at 960 pixels per second, you need 960 Hertz, 960 FPS on your games. That's insane. And that's not even very fast. You see that the test is taking about 4 seconds to go from left to right. So let me explain you what is this speed measured in pixels per second. So basically we have a 4K screen, and how many pixels do we have? We have 3,840 pixels here. So all the pixels we have, and we have 2,160 pixels here. That's all the pixels we have. So if the object is moving at 960 pixels per second, it's going to take 4 seconds to go from left to right. Okay? It's gonna take 4 seconds. Why? Because if I multiply 4 by 960, I get 3840. You can see it better here. If we divide the screen, we have now here 1920, and we have 1080 here. We have 1080 here. And if we divide the screen one more time, then we have here 960. So we have 960 4 times. So it's going to take 4 seconds to go from one side to the other on the screen. So if we want an object moving on the screen and taking 4 seconds, so on a 4K screen, if we want an object moving this fast and looking as clear as this, we need 960 Hertz, 960 frames per second, okay, on our games as a sample and hold. Why? Because a sample and hold display is basically, what that means basically is that each frame stays on the screen all the time until the new one comes. So if you have 120 Hertz, and that means 120 frames in 1 second. So you have 1 second, you divide that by 120, and we can multiply that by 1000 to get the result in milliseconds. So then what we get here is 8.33. Okay? So this is how long each frame stays on the screen on this LG OLED at 120 Hz. So each frame that we see, it stays on the screen 8.3 milliseconds. And the Blur Buster's law gives us the relationship, the exact relationship that we have when talking about persistence and motion clarity. Let me increase the window size here, the zoom. Okay, so let me show you the law here. This is a representation of the Blur Busters law. 1 millisecond of persistence is equal to 1 pixel of motion blur per 1000 pixels per second. So how can we get 1 millisecond of persistence here? So that's gonna give you 1 pixel of motion blur. So it looks clear. How can we get 1 millisecond here? Well, instead of 120 hertz, we need 1000. So we can cancel this and get 1 millisecond. That's how. Okay. So this is an approximation. This law is, the law is the real number. The 960 is an approximation, and the reason why they are approximating in that way is so you can explain this better. Okay, because if you multiply this by 2, you get 1920, which is the resolution, is the amount of pixels on the horizontal axis for a 1080p screen. Okay, that's it. That's the Blur Busters law. So let's think about that for a moment. What does that mean in terms of resolution? Okay, does that mean that a 4K screen looks blurrier than a 1080p screen? What's the difference between, based on the Blur Busters law, do we need more motion clarity the higher the resolution goes? Okay, well, let's think about that. So if we have a 4K screen and we want the object to look perfectly clear when it takes 4 seconds to go from left to right, then we need 1000 hertz, okay? 1000 frames per second. So what if we want the object to look perfectly clear when it takes 2 seconds? Then we need double. We need 2000 hertz, 2000 frames per second. So what about a 1080p screen? On a 1080p screen, how long is the object going to take to go from left to right at 960 pixels per second? It is going to take 2 seconds. So on a 1080p screen, because you have less pixels at 960 pixels per second, it is going to take 2 seconds. Okay? So the same motion clarity on a 1080p screen is going to mean that you have a perfectly clear motion when the object is moving twice as fast. Okay? But you have a perfectly clear object that has half the resolution. Okay? So that doesn't mean that the 1080p motion clarity is going to be better. This only means that having a higher resolution, so if you have a 4K screen and you want perfect motion, you want 4K in motion when you are moving this fast. So if you want the object to move 2 seconds and takes 2 seconds, then you need double the motion clarity. In that case, you need 2000 hertz. That's what it means. So the higher the resolution, the more motion clarity you need to keep that resolution in motion. Why? Because you have more pixels and it is going to take a higher speed, basically. So yeah, just to formulate that one more time, so it is more clear. So let me paint here the screen one more time. So this is 4K, 3840 pixels. Okay, so we have here 1920 pixels. So at 960 pixels per second, this is going to take 4 seconds. It's gonna take 4 seconds at 4K, and it is going to take 2 seconds at 1080p. So same speed, the object is moving twice as fast at a lower resolution. So if you want the object to look clear on a 4K screen if it only takes 2 seconds instead of 4, you need double the motion clarity. So if you want the same motion clarity for an object taking the same time to move from left to right at a higher resolution, you need a higher motion clarity. That's what it means. So basically, if you have an 8K, then you need again double. 16K, you need again double. So what is the maximum motion clarity that would make sense? Let's say the limit that, human limit, basically. So I don't know about you, and I'm not sure if this is scientific here, but myself, I am not going to track an object that is going to move faster than 1 second. And I tested this myself. So if the UFO test is moving left to right, and it is 1 second, that's as fast as I am willing to eye track the object. Faster than that is just too fast. So on a 4K screen, how good the motion clarity needs to be for me to be able to see that clear? Well, I need 4,000 frames per second. I need 4,000 hertz, 4,000 frames per second for me to be able to see that. Okay? Because at 4 seconds, so if it takes 4 seconds, at 4 seconds, I need 1,000. So at 2 seconds, I need 2,000. And at 1 second, I need 4,000. Okay? So that is the highest refresh rate that I am going to need for a 4K resolution. What about 8K? So at 8K, we need 8,000 hertz. If you want at 8K an object to look perfectly clear in motion, moving left to right and taking 1 second to go from one side to the other of the screen, you need 8,000 hertz, 8,000 frames per second. What about 16K? You need 16,000 hertz. Okay? We can call that 2,000. Now we are there already. Let's just call that 2,000. 20,000. I'm sorry. You need 20,000 hertz. No, not 16,000. It will be 20,000 hertz. Okay? Let's just call that. So there you go. Let me know if you have any questions. This might look ridiculous. Like how is that gonna be ever possible? Are we going to be alive for 16K, 20,000 frames per second? I don't know. But it is going to be fantastic for sure. Imagine a VR headset, 16K, 20,000 frames per second. Okay? You can move your head like this fast, and everything is going to be clear. It's gonna be almost true to life. Let me know if you have any questions.